This is the third section of a four-section module on centrifugal pump principles. This section covers internal components. Centrifugal pumps have 6 main internal components: the pump shaft, the impeller, wear rings, the volute, packing or mechanical seals, and bearings. The internal parts of a centrifugal pump are mounted on the pump shaft. It's a single piece of metal that's been machined to fit the pump perfectly. The shaft is usually made of stainless steel or some other corrosive-resistant material. And for a very practical reason, replacing broken or worn-out shafts is expensive. Some pumps have a shaft sleeve, or metal cylinder that fits over the shaft and protects it from damage. It's easier and cheaper to replace this sleeve than the shaft itself. This circular device is an impeller. The impeller fits snugly on the shaft and is usually pressed on. It can be held in place by several methods, but the most common is with a key and keyway. The impeller is the most critical part of a centrifugal pump. Why? Because its size and shape and the speed at which it turns determine pump capacity. There are 3 types of impellers: open, semi-open, and closed. Open impellers basically are vanes mounted on a shaft with just enough backing or shroud to keep the vanes rigid. Semi-open impellers are completely covered on one side of the vanes. Closed impellers have shrouds covering both sides of the vanes. They also have a central hole or eye on one or both sides. That hole lets fluid enter the impeller. Impellers are also classified as single or double suction. With single suction impellers, fluid can enter only one of the impeller's sides. That can cause problems such as imbalancing thrusts in the direction of the suction. In high volume or high discharge pressure pumps, that problem can be serious. It's resolved by using a double suction impeller. This type lets fluid enter both sides of the impeller. That makes the thrust generated on one side of the impeller counter the thrust from the other side. Pumps also come in stages, single or multiple. A single-stage pump will work fine for many applications and will raise pressure sufficiently. But there are times where more discharge pressure is needed. It's possible to raise that pressure by increasing the rotation speed of the impeller or by increasing the impeller size. But that's not generally done because of design and material limitations. That's where multi-stage pumps come in. They have 2 or more single-suction impellers mounted on a single shaft. The discharge port of the first impeller is directed to the suction port of the second, and so on through additional stages. When the fluid flows from one stage to the next, fluid pressure is increased. We know the impeller has to rotate. In centrifugal pumps, there's a space between the impeller and the casing so that the impeller won't rub against the casing. The space keeps both the impeller and the casing from wearing out, but also allows the fluid to leak back from the discharge to the suction side of the pump. Wear rings are installed in this space to control fluid leakage, but not to stop it altogether, since some leakage is important for lubrication and for counteracting the thrust and radial forces that build up inside the pump. When wear rings are attached to casing, they're called casing wear rings. These are called impeller wear rings. They're fitted to the impeller. Some centrifugal pumps are fitted with both casing and impeller wear rings. Remember the volute we talked about in Section 1? It's the chamber that's wider at the discharge nozzle than where the fluid leaves the impeller. That increased area lets the fluid slow down, and as it does, some of the fluid's kinetic energy is converted to pressure. Volute casings are either single or double. In the single type, the impeller and the volute are offset from each other to give room for the increasing size of the volute. But there can be a problem with this setup. Internal fluid action in the volute tends to set up unbalanced radial forces. To reduce those forces, some centrifugal pumps use a double volute casing. The double volute casing provides a second guiding vane to split and balance the internal radial forces. There are other advantages of double volute casings. They give the casing greater internal strength. They also reduce some of the stress load on the casing walls. There's an alternative to the volute. It's called a diffuser. It too has a chamber, but its chamber doesn't increase in size the same way a volute's does. Instead, there's a series of stationary vanes that are arranged around the impeller and direct the fluid outward from the impeller. The diffuser's vanes are further apart at their outermost point than at the edge of the impeller, so they create a series of widening chambers that function as a volute does in converting kinetic energy to pressure.